Hi, this is Barry A. Simpkins speaking. I'm the inventor of the Simpkins Infinitely Variable Automatic Transmission, or CIVAT. The CIVAT is a type of infinitely variable transmission, otherwise known as an IVT. An infinitely variable transmission is like any CVT in that it has continuously variable change in output ratio, but infinite range, which means that it can go all the way down to zero output speed, regardless of the input speed. Now the CIVAT is unique because it uses ratcheting technology, which is positive and efficient. And in this case, the CIVAT is very low pulsing for a ratcheting drive. Generally, the output speed is 0.1% constant across all ratios. There are some ratios where it reaches as high as 6% at very low speeds. A refinement of this transmission can get down into the 0.01% ripple possible. It's more efficient than cam-based ratcheting IVTs, which I will explain in the Word document if you request that. Now, this is the first proof of concept prototype with no design refinement. Came right out of the CAD system as you see it. No changes are made to this. Now, like all transmissions, it has an input, output, and a means of controlling the ratio of the output to the input. In this case, with a ratio control lever. The input is the chain sprocket back here in this magenta piece as a unit. The output is this output sprocket and this red ring behind it. I have white tags of tape that you can see on each of the input and the output so that you can easily see what the ratio change is. Now I'll demonstrate. I'll start off at zero output. So you'll notice that the output is not moving at all, but the input is moving. Now if I move this lever to the left, I can change the ratio and raise it from 0 gradually up through and up to a very high ratio, in this case close to 1:1, and then I can bring it back down to 0 and bring it to a stop, which is like a torque converter, except this is very efficient compared to a torque converter, and it's always engaged. Now this prototype, you notice I've got it mounted on a bicycle frame, and I did that for testing. So in the testing, I wanted to have this prototype the way you see it so that I could test out the proof of principle and then make refinements to it to put it on a bicycle with a bicycle hub that you see here. So this transmission will go inside of this hub. This sprocket will be replaced with a plate that'll bolt to this flange, and then this will be the drive wheel of a bicycle I can test out. Now, although it's on a bike frame and will be tested as a bicycle transmission, ultimate purpose of this transmission is to be used for cars, trucks, and machine drives, and possibly energy recovery systems that use a flywheel. I will do a moderate redesign of this transmission prototype in order to get it onto a bicycle to do the testing so that I can determine what the power, torque values are and what the response is required for this lever. This transmission, as you see it here, is designed for 1/3 horsepower output at 300 RPM here on the output. So as you can tell, it's a fairly power or torque dense transmission. Now, one of the features of this CIVAT is that the control lever lends itself for automatic operation. So as you can see, I've got a rubber band down here, and the rubber band rudimentarily is representing some sort of spring mechanism that will push this lever into a high ratio, so you can see that it's a high ratio. And if I put a load, as an automatic transmission should do, put a load on it, it goes to a lower ratio. Now this also, taken to the extreme, has overload protection, so if I actually try to stop this with too much load, notice that the output stops completely. That protects upstream and downstream mechanisms as well as the transmission itself from being loaded, so you can overloaded, so you can define what force is required to protect the overload. Now I'll go through the ratios again. Start out at 0 output and gradually move it to the left, move the lever to the left, and you can see the ratio goes up, the output ratio goes up to a high gear and back down to any low gear you want, including a stop. We want to develop the CIVAT from this basic technology to a much more refined transmission or a series of transmissions for hybrid vehicles and kinetic energy recovery using flywheels. So you could have regenerative braking using this through all of the speeds of the flywheel to take energy, pump it through here, the CIVAT, and into a flywheel, and then another CIVAT to pump the energy back from the flywheel into your vehicle, saving a lot of energy, much more efficient than electrical energy recovery systems. So if you're interested in developing a technology that uses this infinitely variable transmission, which has potentially a very, very smooth output, probably in the neighborhood of less than 0.5% or better of ripple all the way across the range, and much, much better than that in most of your ratios. We are looking for strategic partners and investors. If you're interested in this transmission, you can contact us for more information, and we will send you a Word document and the proposal that we've prepared for our strategic partner business possibilities. Thank you for watching this video. I'm Barry Simpkins. Goodbye.